Hello and welcome to a new video about hydraulics. This time we're going to talk about proportional valves. Well, choose the valve proportional to your application. No. Yes, of course, but no, this is not proportional valve. Proportional valves can change one attribute of the liquid, of the hydraulic fluid, according a proportional signal. In proportion. So there are proportional pressure valve. I tell the proportional valve how much pressure do I want to have. Proportional pressure valve. Then the proportional flow valves. If I set a small signal to the valve, there's a little bit low flow. If I set a higher signal, it should be higher flow. And if I set the maximum signal, it should be maximum signal. So it shall be maximum flow through the valve. Okay. And there are proportional wave valves. It's just like a wave valve. However, it's that the flow is not fully to one extent, but can be proportional to the signal to the valve. Small signal, small flow, big signal, big flow, signal in other direction, other way. Okay? These are proportional wave valves. How is this working? Well, usually we do have current. There is current, which is adjusting the valve. So there is a coil, something like this. However, a little bit more sophisticated. This is just a spool, how you buy it, and the coil is then really done on purpose. This is just for sanding. So let's have a look. From the outside, a proportional magnet, because this then is a magnet, an electromagnet. If there is current running through these wires, then suddenly there's an electric field inside. You have heard this in electrotechnic. Coil producing a magnetic field inside. From the outside world, it looks like this. There is some cover simply, and here's the plug. This on the top side is only a plug. This one is a typical style of plug. You can push it away to the top in this picture, and there is also, it's usually screwed in, because it's not only plugged, there is also a screw in, and it's really tightened, this screw, because hydraulics usually is a little bit shaking or something like this. There's vibration, so it should not get loose. So this is how it looks like. And there is also a rubber sealing. You see this black part here. This is a rubber sealing. This is just, if there is water or if there is just a spill, it should not harm the electric components. Okay, so there is the connection, and everything else is underneath this protective tube here. If we cut this open, underneath it looks like this. So now this here shall be the coil. This orange thing is the copper, and it's not a solid copper piece how it looks there. It's a coil spooled. So even cut this open, underneath there is also a tube which is shut here, and this tube, inside there is the liquid pressure. Okay, inside there is the liquid pressure. So this is one piece. This black or gray thing here, we'll talk about this. In reality, you probably don't even notice that it's there. It looks like a part of this tube. It's just here in the picture that it's really that significantly different color. But okay, we'll come to this, what the meaning of this is. Cut this also open, and here we have it, how it looks inside. So this here is the moving part. This here is the moving part. It's simply called Armature, Anker. In German it's Anker, Armature. So this is moving. This is soft iron. Well, soft iron, you know, it's not soft, it's not cozy iron, yeah? It's magnetically soft. So it's easy to magnetize. And if there is now current running through this coil, yeah, what is iron doing? It's getting sucked into the magnetic field. It sticks to a magnet. Yeah? And here, this iron part, this big iron part, is then sucked into the coil. So this will move to the left. This direction will be moved. If here is current, it will be moved in this direction. The more current is running, the more force we have in this direction, because the bigger is the magnetic field. The more current, the bigger is the magnetic field, yeah? The more force will be applied to the armature to the left. Okay? So, this movement I can use. In standard switching valves, yeah, we only turn it off and on the coil, and this will then push from this side or push from the other side, and this is how electromagnetic operation of a coil is working. In an proportional magnet like this, yeah, it's working pretty much the same way. So what do we have? Yeah? What is our goal? What do we want? Yeah? So if we have a look, there will be movement. So this is the rest position, because this is where we will be without current. Okay, how we will achieve this I will show you afterwards. So this is the rest position. Usually the rest position is reached with a spring. So here is a spring force. The further we move into this direction, the higher the spring force is. Okay? And then we do have different currents. Yeah? We have here somewhere a maximum current. Yeah? We have a zero current, then we are here. And of course, if we have 50% current, it would be nice. It would be nice to be at the half. If we have, I don't know, 75% current, yeah, it would be nice that we have 3/4. Yeah, and also here, yeah, it would also be nice to have 1/4 of the movement. Yeah? So we want to have a linear relationship between the current and the position. This is the task. This would be wishful. If I send in 0 amps, no movement. If I send in maximum amps, maximum movement. If I send in half of the maximum, I want to have half movement. Okay? Half of the movement. If the coil is even a little bit to this position more, yeah, there is then the current simply dropping. Yeah, so this is here there is no resistance from the spring, and suddenly, ping, we reach the string. Boom, the string will be forced and will take the current. So we want to have this zack, 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 zack. We want also to have this 0.25, 0.5, 0.75, and here full movement. This would be ideal, to have a linear relationship between the current and the movement. Yeah? And now let's come back to our picture. This is exactly, because you know, it's not that easy to achieve this, because there's magnetic field and this is distributed somehow, yeah, and this is exactly where this black thing I said, where we put in this black or gray thing here. This is a control cone, and the control cone's task is only to make this possible, this linear relationship, to make this possible, that we do have almost, that we do have almost 50%, 50%, 75%, 75%. Yeah? So this is a part which will help us control the valve linearly. Yeah? This is why I did this, is it in? Yeah? In the last cut. How is this then built in a real valve? Here is a real valve, or picture of a real valve. It's again my construction. It might look like this. Here is the proportional magnet, the cover, the armature, and the armature is now pressing against this cone here. The cone is resting. Let's open this also. The cone is resting in a hole here. So if there is the pressure coming, it will only be able to open the cone if the pressure, the pressure force is high enough to overcome the force which comes from the magnetic field. So this is a proportional valve. If I have high current here, I need high pressure, then I get high pressure back. If I have low current here, I need a lower pressure, and I get a lower pressure out. It's a proportional valve. Okay? This is how such things looks like. So there is a coil. The coil is producing a magnetic field. The magnetic field is pulling in an armature. The armature is acting inside the valve somehow with a force. It might look like this. This is a little bit from an angle. Or it might look like that we have a spring here, that the armature is not directly connected to the cone. It's loading a spring simply. So this is a force loading. Here we will move, the armature will actually move. In the other case, the armature, this is movement driven, the other one is force driven. Okay? If I move here in, I will load the spring, and they're not that easy to open this. The rest is just looking the same. You see, this cone can be pushed inside. That's the difference. This is how proportional valves work. So these are proportional flow valves or pressure valves or something like this. The real magic is happening inside this cone here. The cone, the control cone, and this is the working principle simply. Proportional valves, proportional flow valves, proportional pressure valves. Next time we are going to talk about proportional wave valves and how they are looking inside. I will also show you there is a little bit more because they are used quite often, proportional valves. You quite often need the case that something is moving slow and fast. So there is, or anything in between. How this is working and how many of these proportional magnets we need, we will be talking in next video. For this time, thank you very much for listening. Goodbye.